Welcome to AI Paper Drop. I'm Alex.
And I'm Maya.
Imagine an AI assistant on your phone that remembers every single conversation you have ever had and every manual for every device you own, but it responds instantly. No loading bars, no lag. Just immediate answers based on a lifetime of data.
Wait, that sounds like a dream. Right now, if I ask a local AI to look at a long PDF, I can practically go make a sandwich while it processes the document. Why is that so slow?
Exactly. It is called a pre-fill bottleneck. For an AI to give you an accurate answer using a technique called RAG, it has to actually read and process the retrieved text first. On a massive cloud server that is fast. But on your phone, it is a nightmare.
So the AI is basically like a student who is brilliant, but has a weird rule where they have to reread the entire textbook from page 1 every single time you ask a question?
That is a perfect analogy. It is not just reading. It is calculating the relationship between every word in that text. The longer the document, the longer the wait. We're talking about 27 seconds of agonizing silence on edge hardware just to start a sentence. For a real-time assistant, that is completely unusable.
So the problem is the act of reading. How do you get around that without just not reading the documents?
You change the architecture of the brain. Most AIs use transformers, which have this memory called a KV cache. The problem is that this cache grows as the text grows. It is like a scroll that gets longer and longer, and the AI has to scan the whole thing every time. But this paper uses something called state-space models, or SSMs.
SSMs. I have heard that term. Are they just a faster version of the same thing?
Not exactly. They handle memory differently. Instead of a growing scroll, an SSM compresses everything it reads into a fixed-size mathematical summary called a hidden state. Think of it like a save game file in a video game. Instead of playing through the whole level again to get to the boss, you just load the save file, and you are exactly where you need to be.
Okay, I get the save game part. But does loading a summary mean the AI forgets the details? Like, if I load a save file, I might lose the nuance of how I got there.
That is the magic part of this paper. They introduce precog, which stands for pre-computed context injection. Because of the way SSMs work, this hidden state is actually a complete summary. The researchers found that you can pre-encode your documents offline as these states. When you ask a question, the AI does not read the text. It just injects the pre-computed state directly into its memory.
Wait, it just drops the memory in? Like a brain transplant?
Basically. And because these states are not tied to a specific position in a sequence, the AI does not get confused. It is just there. It is an O of one operation, meaning no matter how big the document was, it takes the same tiny amount of time to load the state.
I am skeptical. This sounds too good to be true. Does it actually work, or is it just a rough approximation of the text?
That is where the evidence gets wild. They proved mathematically that injecting the state is algebraically identical to reading the full text. There is no loss in quality. They tested it on a model called TNNSOLM, and the prefill latency on edge hardware dropped from 27 seconds to less than 6 milliseconds.
6 milliseconds? I cannot even blink in 6 milliseconds. That is a 4,500 times speed up. That is not an improvement. That is a total transformation of the experience.
It really is. And it is not just about speed. The storage is way more efficient. These memory states are 85 times smaller than the caches used by transformers. They found that an archive of 10,000 document chunks only takes up about 1.9 gigabytes. You could actually fit a massive personal library in the background of a mobile app without killing your storage.
So if I have 1,000 PDFs of my medical records or my company's entire codebase, it just sits there as a collection of these save game files, and the AI just swaps them in and out instantly?
Exactly. And they took it a step further with something called structured memory consolidation. They created a way to organize these memories hierarchically. It is almost like how humans remember things. You have short-term episodic memory for the conversation you are having right now, and then you consolidate that into long-term semantic memory.
So it actually mimics a cognitive process. Does that mean it can prioritize what is important?
Yes, they actually built a fidelity versus storage dial. You can decide if you want the AI to remember every single pinpoint detail, which takes more space, or just the general gist of the conversation to save room. It allows the AI to maintain a persistent history of your life without the system slowing down as that history grows.
It sounds like we are moving away from AI as a tool you query and toward AI as a persistent entity that actually grows with you. Because the memory is local and instant, it actually feels like a part of the device.
Right? It removes the wall between the user and the data. We have spent years trying to make RAG faster by optimizing databases, but this paper says the real problem is the architecture of the model itself. By switching to state injection, they have effectively deleted the loading bar from the AI experience.
It makes me wonder why we are still clinging to the transformer architecture for everything if this is possible. Is there a catch?
The catch is that we have spent a decade optimizing transformers. Moving to SSMs is a bit like switching from a gasoline engine to an electric one. The infrastructure is different, but the performance gap for this specific use case is just too big to ignore.
So the big takeaway here is that the lag we associate with on-device AI is not a hardware limitation, but a software choice.
Exactly. This technology turns a slow, stuttering assistant into a digital brain with a perfect, instantaneous memory.
If you're enjoying this, follow or subscribe to AI Paper Drop wherever you listen. It really helps, and we have a new episode every day.
Paper by Anusha Mudun Gopal, Eris Perbadian, Christopher D. Carlson, M. Anthony Lewis, Jonathan Tapson. Produced by AI Paper Drop.